What's up, biology class? Today we'll be showing you Anbu's and my presentation on how epilepsy works and the inner workings of cell signaling and gene expression and all that stuff with it. Good job, Anbu.
A description of the cell signaling pathway that is disrupted. Generally, what happens in neurons and stuff is that the GAB mechanism in basically inhibitor is an inhibitor. So when neuron excitement is like going crazy or whatever, they send these electrical signals, and then the GAB receptor or inhibitor or whatever will stop it. And how this is disrupted is when this actually mutates and doesn't work correctly anymore.
In this picture, for example, you can see how the GABA receptors work. Basically what happens is when their activator binds to it, it lets ions flow through the channel, which will then allow it to actually do its job and inhibit the process of the neurons actually activating.
What causes the disruption in this pathway?
That's a great question. So when the GBA is inhibited, it can lead to, well, obviously an increase in seizures because it's not controlling that neural excitement anymore. Genetically, if it mutates, you can have a lot less efficient ones. Proteins can be missing from it, or sometimes if it mutates, it doesn't create as many, which can allow for easier seizures as well.
Does this condition have a genetic basis for the disruption in the pathway? And if so, how is gene expression involved?
That's a great question. Basically, gene expression is very crucial in epilepsy. This condition, a lot of the times when it doesn't work or when it's inhibited, this is what causes the condition to occur in the first place. When these signals or receptors are malformed or ion channels are mutated, it can cause epilepsy because these GABA receptors or whatever, they don't work correctly. Therefore, it's not able to stop at this much neural excitement, meaning that when gene expression is incorrect, it can lead to incorrect receptor assembly or subunits not even working properly overall.
What protein types are part of this pathway and how are they affected?
This pathway involves receptor proteins. Mutations in their proteins can alter reception function, impair receptor subunit mRNA stability, disrupt receptor subunit protein folding, and interfere with receptor trafficking.
What are the effects of the disruption in this pathway for the organism?
It causes idiopathic generalized epilepsies like childhood absence epilepsy, juvenile myoclonic epilepsies, and febrile seizures.
What possible treatments exist for this condition?
There are many medications. Monotherapy is preferred, but polytherapy is often necessary. Surgical options include resective surgeries and responsive neurostimulation. Dietary therapies, like the ketogenic diet and the modified Atkins diet, can be alternative, especially in pediatric cases. Give an example of a drug that is used to treat epilepsy and explain how it works.
So one common example of a drug that is used to treat epilepsy is gabapentin, where it binds to the subunit of the voltage-sensitive Ca2+ channels. What happens is when this drug crosses multiple lipid barrier membranes, it eventually binds to these voltage channels, which can often lead to an increase in the efficiency of the GABA synthetic engine. A lot of the time, people have not found out how specifically yet it increases it, but nevertheless, it does. This example, and all of the previous examples that we've had, as well as the sources we used, show that altering these pathways can either lead to epilepsy or increasing GABA efficiency by reducing it.
So overall, GABA is both a receptor and a thing that binds to the receptor that inhibits neuron excitement, which can often lead to those seizures and epilepsy, because if they send too many electrical signals that aren't meant to be, then it can cause uncontrollable muscle spasms, because those electrical signals aren't supposed to go through that it would normally inhibit. But when those things mutate or those things don't work in this, like for example this channel, then it can cause epilepsy. Anyways, thank you for your time and have a great day.